Today we're going to go through the requirements for the longitudinal modes. So this is directly from your book. In chapter 6. So there's the phugoid damping requirements. And notice that over on the right, there are no requirements for part 23.25, but most people use the mil specs on the left when they're designing the aircraft. So you find the damping ratio, and then you have to meet those specifications. The formula I need to give you is the time, the T subscript 2 subscript pH. This thing is the time to double amplitude. So to meet level 3, you can actually have a divergent phugoid. And the way you calculate that, I'll show you in a minute. Didn't want to do that yet. And then down here are the short period mode requirements. Notice you have to pick the flight phase. A and C are A is the maneuvering and C is terminal. And B is a cruise, so that's what we'll be using for our BizJet. And these are mil specs as well, but people use them to design non-military aircraft. Down here, the real requirement is that the damping ratio must be heavily damped. So these are still good guides up here. And then there's a requirement on We're back on. Can you hear me now? Yeah? Looks like I might have to plug this one in. Let me do that real quick. I think my power is going. Okay, you can still hear me, right? Yes, sir. All right. So you plot the real part of the route. If it's stable, it's negative, so you're over here. The imaginary part is the vertical here. And omega n is then the magnitude out this way, because omega n is the square root of the real part squared plus the imaginary part squared. So that is the magnitude of the imaginary root, or sorry, the complex root. And then the sine of this angle is the real part over omega n, and that is the formula for the damping ratio. So you can actually plot the damping ratio limits in the complex plane, and then the damping ratio limit as an angle line away from that. But it's really more straightforward just to go ahead and use this chart here and the chart up here. All right, so let's do this for the BizJet after I show you how to calculate the value, that n over alpha thing. So the first thing I promised I'd show you is the phugoid. The time to double amplitude is calculated from this formula. So this is only if you have a negative damping ratio. It's got to be unstable, because what it's saying is that you get an oscillation, but it grows. And so the time to double amplitude is what you're calculating. And so you simply plug into this formula if you have an unstable phugoid, and then you need to satisfy that level 3 requirement. Of course, level 3 is not good, so you'd rather not have that. And then the short period the n over alpha, the formula is this. And if you multiply and divide by alpha, you find out you move the S up to the top, and you get Q bar SCL, so that's lift, divided by weight. All right, CL alpha times Q bar times S is lift, and that's lift over weight per degree angle of attack. So that's why they call it G's per alpha, is because the numerator is the lift, the denominator is the weight, and it's per angle of attack. Don't ask me why they use that. It has to do with the wing loading, but other than that, the specs are set based on that Cooper-Harper pilot feedback. So let's do the BizJet. So you remember the requirements for the BizJet? Let me write what our damping ratio was for the BizJet up here, and then we'll jump back to the screen. So for the BizJet, we had calculated a damping ratio from the roots of 0.05. And then we have a natural frequency from the roots of 0.09 radians per second. So we have to jump back and forth here because I can't project two things at once. Here's our requirement. So we had 0.05 the specs say if you're bigger than 0.04, we have level 1. So we say check. Our damping ratio is big enough. So jump back. Everybody see how that works, right? It's pretty straightforward. All right, the next thing we need to do is calculate N over alpha, which means we have to look up the dynamic pressure for this biz jet, the lift curve slope, and the wing area and the weight. So we go back to the chart for the biz jet. We're at 133.84 for the dynamic pressure. The lift curve slope for the airplane is 5.84, 13,000 pounds, divided by 232 feet squared. And we get 13.95 Gs per radian. And it's per radian because the lift curve slope is per radian, because it's on the order of pi. So now we have to go back to the chart. Remember this number, because we have to see if it falls within the bounds. And I wrote down the damping ratio too, did I or not? Oh, forgot to do that. We'll have to jump back. So let's go to this chart because we just did that. So what was my N over alpha? It's 13 something, right? So check my line there. Is that in the right spot? Be careful. Notice that's a log scale, right? So 13, this is 10 here. 20 is over here, 30, 40, 50, 60, 70, 80, 90, 100. So 13 is somewhere in here. So I've drawn a line up at the N over alpha, and then the intersection with level 1 and level 2 give me the points here. So here's what I'm looking at here and here. So we read off there, log scale again. 1, 2, 3, 4, 5, 6. So it's about 6 point, maybe 7. A little bit less than 7. And then down here, we're at about 1, right? So I have to be between 7 and 1. So how are we doing? Natural frequency, let's go back to that. And we're doing the short period now. 2.83. So it's definitely greater than 1. And it's definitely less than 7. And the damping ratio, short period, was 0.35. So now we have to go back to the other chart and see where we fall there. Following, got to jump, pick the right chart, get the data for the airplane and go back to it. So this is level 1, based on those charts with the hashed lines. I want to find out what this is. So now we're looking at this chart, and we had a damping ratio of 0.35, just barely, but it's within the minimum for level 1. That's flight A and C. Oh, I need to be looking over here, don't I? Category B, so 0.3. So my 0.35 falls within the range of 0.3 to 2. So that's how you do it. You have to find the right flight category. This is cruise, that's what we're doing. And then you compare the routes from the airplane to that.
Category B means it's a cruise?
Yeah, category B is the cruise flight phase. And that was the condition for the data that were given for the airplane. I'd have to go like A, I think, is maneuvering flight, and C is terminal flight. Let's go back and look. Category A, non-terminal precise flight path control, like fish spotting, air-to-air combat. B is cruise, climb, loiter, and C is accurate flight path control, takeoff, approach, landing. So let's pull up the routes for the jet fighter because we had those. And we did everything, right? Yeah, the Fugo only had a damping ratio spec. There was nothing about the natural frequency. And we did the short period damping ratio and natural frequency, comparing it to the 2 different charts. So now we have the fighter. It had a complex mode with a damping ratio and a natural frequency that was given, but then it had 2 real routes. So this is non-standard stuff. So if you look at this, this looks kind of like a fugoid mode because it's low frequency, right? Short period is faster frequency. And this is what should be the short period mode, but it's degraded. And the first thing we notice is, well, definitely it's not going to meet any kind of specs because we've got an unstable mode here for the short period. So that's definitely bad. And that typically they will add a stability augmentation system, a output feedback flight control system. And then how about this? We go back to that chart for the fugoid, and this does satisfy level 1 for the mil specs. So that's good, but the short period mode is bad. And so it has to be fixed up with an output feedback controller. So that's how you do the longitudinal modes. You get the routes, you find the short period and fugoid modes, find the damping ratio, natural frequency, and then compare it to the charts. And it tells you whether you're good or not. The lateral directional modes we'll go into in our lecture next Tuesday, not next Tuesday, but a week from this coming Tuesday. So I'll show you how to do those specs for the Dutch roll mode, the spiral, and the roll mode. That's it for today. It's been good being in class with everybody. I hope you guys thought so too. We go online after Thanksgiving, and then we have a final, and we're done. So everybody have a safe Thanksgiving, safe travels if you're going somewhere, and stay safe when you're doing all of that. Any questions? Yeah, about what's going to happen?
For this last exam you just took, are you just going to like send us a PDF with the graded version of it over?
Yeah, I hadn't thought that far ahead. Yeah, that'll be the only way I can get it back to you. Yeah, I've done that before. It takes 18 clicks of the mouse in Blackboard to upload a file to you, but I'll do it. So, and then if you have any questions, we can set up a Zoom meeting. But look for a Zoom during the regular class time on Tuesday after Thanksgiving. All right, see you. Have a good holiday.